Hi there and welcome to Magic. In this video I am going to show you some of the more advanced features of Magic. I'm going to dive into Hyperlambda and we are going to look at the internals of how Magic does what it does. Here I have the latest download of Magic. I'm going to open a terminal window. I'm going to go into that folder and then I'm going to type code : that opens up Visual Studio Code in that specific folder. So this is the way it's going to look like when you open it for the first time. When you do, you're first going to have to, in one terminal window, going to have to change your directory to frontend. Then you're going to have to type npm link, and then you're going to need another terminal window which you change into magic.backend, where you're going to have to type .NET run. This .NET run command starts the backend, and npm link will simply include the Angular packages that you need in order to be able to successfully serve your frontend, which is built in Angular. ng-serve serves your frontend. Now, you might have to open up or expand magic.backend and open up the appsettings.json file for here to change your database connection strings. I only have MySQL, so I can't be demonstrating Microsoft SQL Server for you on this machine. However, it doesn't really matter because they are the exact same processes for wrapping a MySQL or an MS SQL database. And especially the passwords probably needs to be changed. This happens to be my MySQL password. The one thing you must leave as is this part, database, with the parentheses around it, because this is being dynamically replaced during runtime by the Magic core. So now my application is up running. I can open Google Chrome and I can go to localhost :4200. When you enter it initially the first time, it will look like this. Now, this actually allows you to override the backend URL. My backend happens to be running at, as you can see here, hopefully, somewhere, happens to be running on localhost :55247 port. So this is the default correct value pointing to your Magic backend. But you can actually use the same frontend to administer multiple backends, simply overriding the URL before you log in. I'm going to log in with root, and all I'm doing now is the exact same thing you need to do as you initially start Magic. You download it and you want to try it out. You'll need .NET Core, Angular, Node, NPM, and you'll need some sort of editor. I'm using Visual Studio Code, but you can also use Visual Studio on Windows. So I'm now logged into backend or Magic, and here you can see that my current version is 5.5.0, which happens to be the latest download at this point in time. And I can start CRUDifying my database. If I choose MySQL here, for instance, then I can select the database, can select the CRM. I can select one table at a time. If I do, I can override a lot of its settings. I can provide log entries that are being logged to my logging implementation when this HTTP REST endpoint is invoked. Can provide authorization. Root, admin means only root and admin users are allowed to access this. Root user means all users in addition to root is allowed to access it, etc. Nothing means it's completely open for everybody, even without authentication or being authorized or whatever, etc. And what you see here at the top is basically the columns for the data table. If I change table from contact to, for instance, notes, you will see it changes accordingly. This is the name of the column here to the left. Then we have the type. The first type here is the hyperlambda type it will be converted into. The second one is the actual database type. Whether or not the column is nullable or not, whether or not it's part of a primary key or not, whether or not it has some sort of like automatic value. For instance, for this column is an auto increment column, the ID primary key of this particular table. Then of course I can choose all tables at the same time, at which point, you know, everything will be codified at once. And it now created 333 lines of code and 36 HTTP REST endpoints for me, which you can immediately look at here. If I now go to, let's do roles, then I can choose the get HTTP REST endpoint for roles, and I can immediately evaluate it, and it's going to return all the roles in my system. If I now do a post, then I can post a new role, which I can refer to as super duper user, right? That's probably a credible role, I imagine. Now I can do get, and I can evaluate, and I can verify that my super duper user has been inserted into the roles table. And of course I can add any of these possible query parameters to my get invocation. For instance, if I want to do role.like equal %duper %, it's hopefully gonna return my super duper user. Or I can do role like admin, or I can do role EQ. EQ means equal, like is the like operator from SQL. I have all the same operators. For instance, here's empty means more than. See, it's not returning admin now. If I do more than EQ, that means more than or equal, etc. Less than EQ means less than equal, etc. So this allows me, and of course I can concatenate multiple query parameters. If I do ID dot less than or equal to 2 and limit 1 and order equal ID and direction equal DESC, DESC for descending. Limit 1, limit equal. There we go. So I can construct any queries, and these are ANDed into the where query of the SQL that is executed towards my database. And of course, post is create, put is update, get is retrieve, and delete is delete. Delete can only delete one record at a time as a security measure. However, you can create the ability to delete multiple records if you want to, but that requires some additional manual work on your behalf. If I do ID equal 4 now, then it's deleted my super duper role here, as you can see. Now, what it actually does is that during the CRUDification process, Magic will create files for you. The name of my database was magic_sample, so it will create a folder called magic_sample where it puts all of my HTTP REST endpoints for that specific database. If I open this, I will see that I have, whoops, sorry, not magic_sample, but CRM. So every single HTTP REST endpoint I have towards this database called CRM can be found inside of here. If I, for instance, want to see the roles, do a search here, roles gets hyperlambda that is automatically generated during the scaffolding process, then I can click on this particular entry here, and I can view the code that was automatically scaffolded up as I was creating this HTTP REST endpoint. So Magic created this code automatically for me. Now, if I want to, of course, I can actually modify this code. And it's actually much simpler than it appears to be, because if I now click Shift-Tab, then it's gonna de-identify. It's gonna move 3 spaces to the left. And the reasons why it is much simpler than you believe is, first of all, the code is obviously syntax highlighted, but also you do have autocomplete. So if I do, for instance, io.files, then it's going to filter according to every single hyperlambda keyword I happen to have in this that, contains io.files in its name. And of course, the naming conventions of hyperlambda slots, which I refer to them as, is relatively intelligent. And the simplest way to play around with the hyperlambda is actually to use the evaluator. And here I can do, for instance, io.folders, list, :/ This is going to list every single folder at the root of my system. And at the root of your system, this is important to realize. The root of my system is not where my web app by default is installed. It is one folder further down. And there's a folder that is called files. I can show it to you. Magic Backend. Here you see the files folder. You see MISC and modules. And then you see it returns MISC and modules here. If I open up MISC, for instance, you see it contains a couple of files here. I can actually load these files. :/misc/ let's see. Okay, crm.sql. So now I just loaded the file in Hyperlambda. Now I want to emphasize all of this is actually happening on the server side. So it's completely hidden from the front end. There are no traces of Hyperlambda in the front end really. To the front end, it just seems to be just another HTTP REST backend. So, but this particular module here allows me to dynamically evaluate Hyperlambda through my browser. Here you can see actually the script that creates the CRM database. And by the way, if you want to play around with a database and you don't really happen to have one, then you can go to Files, you can open up MISC, and you can click on the crm.sql. If I evaluate this, then it's going to create my CRM database. This won't work for me, of course, because I already have that database. Can't create CRM database. Database exists. Can actually make it work. Delete database CRM. Not delete, of course. Drop. Is it? There we go. And now it recreated my my CRM database. So now when you go into the evaluator and you get autocomplete here, it might be a little bit difficult to understand what is actually happening. So let's have a look at it more in detail. Here is the version slot hyperlambda keyword. If I evaluate that, it returns 5.5.0 as a string. Now, to understand what occurs here, we have to have a look at some of the C# code behind. If we look at the C# code for that particular hyperlambda keyword, it can be found inside of magic.backend. Magic.backend have a folder called slots, and slots have a C# file called version.cs. And this is actually the file that declares my hyperlambda keyword. Now here you can see that the version slot has an attribute, gives it a name. It implements the iSlot interface. There is also an async version of this interface. And this interface has one method. So when I do this in hyperlambda, what is actually going to occur is that my hyperlambda is first initially going to be parsed into a lambda structure that is kind of like CLR code-ish thing for Magic. And that thing is going to be used as a syntax tree for executing towards my hyperlambda keywords, whatever they happen to be. And then, of course, this one's going to return 5.5.0. Now, if I wanted to, I could easily create my own keyword here. That means I first need to stop my .NET runtime here. Then I can copy this one simply because it's faster. Okay, let's call it foo bar. Okay, so let's then rename the slot to foo.bar. Let's rename the class to foobar. And let's just remove these comments to make it slightly more easy to read. Now let's imagine foobar takes a list of arguments and we want to add them. Okay, input.value becomes our return here, equal input.children.sum. Then I probably need to pull in link here. X equal x.get int get ex. Int is my type here. And why doesn't this entirely work? Node, yes, because I need to pull in using magic.node.extensions. There we go. And now I can actually, compile and restart my application pool, and I'm going to have a foo.bar slot that happens to return the sum of all the parameters you supply to it. So let's try it out. Refreshing the browser just to make sure that we are reloading our vocabulary. And then I do foo, or actually foo.bar, okay. Tab, colon int, actually we don't need a int keyword, colon 5, colon 7, colon 5, colon 40. I think this is going to become 57, if I'm not entirely wrong. Evaluate, and it returns 57 here. Now, of course, normally you'd want to do input.clear afterwards to remove the parameters. So let's recompile here and run it again, just to get rid of these guys in our results. And simply being left with only the sum. And evaluate. And here we go. So I've now created my own hyperlambda keyword. And of course, a keyword can do whatever you want it to do. You can make it log, create a log entry. You can make it invoke an HTTP REST endpoint, which I, by the way, have actually. HTTP :.get colon https ://google.com. Let's try this one out. Well, there's always a demo troll, right, isn't it? But this one will work in the future. But there's obviously a bug here in my HTTP REST parts of the library. So in addition to having the evaluator, I can also execute arbitrarily SQL. If I want to, I can create database foo_bar, use foo_bar, and of course here I can create table, etc., etc. Or I can use magic_sample, select all from to-dos. I'm not sure if that is the correct name, the table, but it appears to be. And this one allows me to do some basic and simple SQL management of my databases. And of course, everything I've done in this demo, I can either do towards MySQL or MS SQL. If I go to the Crudifier, you see the first thing I choose is the database type. The second thing I choose is the actual schema. And then the third thing I choose is which table I want to Crudify, which can also be custom SQL. It can be all tables or one specific table. So we've had a look at the two latter ones. Let's have a look at custom SQL. Okay, so here in Magic Auth we have, actually let's do another one. Let's do Magic Sample and let's choose custom SQL. Here we have to-dos. Okay, select all from to-dos, where, of course I can't remember the name. Okay, header. Let's use header. Select all from to-dos, where header like. And this is a little bit cool because here I'm actually adding a parameter. I'm dereferencing a parameter inside of my SQL here. And this basically becomes this. So here I can add any number of parameters. I can foo, :string, bar, :int, howdy, :date, etc. And Magic will automatically convert my input arguments to those particular types, depending upon what type I have after my colon here. And then I can dereference the value of these arguments inside of my SQL here. Then I need to select the verb. Okay, get, foo, authorization, okay, root, create. And I now have a foo HTTP endpoint, and we can actually verify it by clicking here. And as you can see, it takes a filter, filter equal sum. Yet again, another demo bug, but you get the point. So anyway, that is the advanced look at Magic and diving a little bit into Hyprland. And obviously I will sort out these two bugs pretty rapidly to make my next demo hopefully become even better than this one. So thank you for watching and have a nice day. And as always, there's a link in the description of the YouTube video for where you can download Magic.